Questions 11 through 20 of the 1998 Pascal Math Contest for grade 9 is what I will cover in this video. The number in an unshaded square is obtained by adding the numbers connected to it from the row above. The 11 is one such number. The value of x is. All right, let's draw this out a little bit bigger. Okay, and let's fill in the numbers. So we've got 5, 6, x, 7, 11. Now, 5 plus 6 is equal to 11. That's how this diagram works. So that means 6 plus x goes here. X plus 7 goes here, like that. So I hope you understand how this works. These two are added, so 11 plus 6 plus x, which is essentially just 17 plus x. These two are added, so we get 13 plus 2x. And finally, we have 60 here. That's what they gave you in the question. So we have to figure out x. Well, that means that this plus this is 60. So 17 plus x plus 13 plus 2x is equal to 60, right? So now you just solve for x. So 17 and 13 is 30. X and 2x is 3x, and that equals 60. So 3x is 60 minus 30, which is 30, and therefore x is equal to 10. So the answer here is E. In the diagram, DA equals CB, so DA is equal to CB, like this. What is the measure of angle DAC? So this is the angle they want us to find out. All right, so let's label that. We'll call it Y. And this angle in here, I will call X. So first, let's look at triangle ABC. This one right here, ABC. In that triangle, as always, the sum of the angles is 180. So they've given us two of the angles already, 70 and 55, and I labeled the other one as X. So we can solve for x. This looks like 180 plus 70 plus 55, which is 125, and therefore x is equal to 55. So x is equal to 55. Now if x is equal to 55, then that means that ABC is an isosceles triangle, correct? Because if that's 55 and this is 55, then these two sides are the same. So that means AC is the same as CB. So if AC is equal to CB, and the question tells you that DA is also equal to CB, then therefore AC is equal to DA. So AC, which is right here, is the same as DA. So therefore, those two are the same. So that means this triangle is also isosceles. All right? So if that's the case, then this angle is going to be 40. Just like how it's 40 there, it'll be 40 over there. So then we just have to look at triangle DAC, which is this triangle right here, and use our formula once again that the sum of the angles is 180. So we've got y plus 40 is equal to 180. Solve for y and you get y equal to 100. And that is the angle they're asking for, angle DAC. So the answer here is B. A three-wheeled vehicle travels 100 kilometers. 2 spare wheels are available. each of the 5 wheels is used for the same distance during the trip. For how many kilometers is each wheel used? So they've got some sort of 3-wheeled vehicle. I don't know what type of vehicle this is, but it's got 3 wheels. And initially you've got, let's call the 5 wheels A, B, C, D, and E. All right? Because they tell you there's 5 wheels. There's 3 wheels on the vehicle and 2 spares. So let's say initially you've got A, B, and C as your 2 wheels that are on the vehicle. So now let's start off the journey with these 3, A, B, and C. These are the 3 wheels that are on the journey. And we go a certain distance, and I'll put distance here. Now we don't know how many kilometers we're going initially, so we'll leave that blank for now. And then after a certain amount of time, we will start to remove one vehicle at a time. Sorry, not one vehicle, one wheel at a time. And let's say the first wheel we remove is A. So if we remove A, we'll have B and C remaining. And we want to add a spare because you can't have 2 wheels, you have to have 3, so we'll add the D, like that. So now this vehicle has wheels with the letters B, C, and D. All right, initially there was A, B, and C. We removed A. Then we go a certain distance with that, and then after a certain time we'll remove the next wheel, which is B. So now we have left C and D, and we have to add a wheel because otherwise the vehicle won't run. So we've got E that we've now added. So then this vehicle goes along with these 3 wheels, C, D, E, for a certain distance. And then similarly we remove C after a certain time, and we're left with D and E. But then we add back wheel A. DEA. And then we go travel with DEA for a certain amount of time. And then lastly, we will remove D, and then we'll have A, EA, and we will of course add back B. Now, I want to pause at this point because there's a clue in the question. Each of the 5 wheels is used for the same distance during the trip. Okay, that's very important. Now at this point, this is distance. Now at this point, if these distances are equal, let's say, how many distances has each wheel traveled? Well, A has gone once, twice, 3 times. B once, twice, 3 times. C once, twice, 3 times. D once, twice, 3 times. And E once, twice, 3 times. So it looks like each of them have traveled the same distance. And they've told us that the total distance is 100 kilometers. So therefore, these must be equal, and when you add them all up, they equal 100. So if each of these distances is represented by x, we know that 5x is equal to 100, and therefore x is equal to 20. Now they're asking for how many kilometers is each wheel used. Well, each wheel, for example, A traveled x, then it traveled x again, then it traveled x once more. So each wheel was used for 3x. So because each wheel traveled 3x, 3x is equal to 3 times 20, which is 60 kilometers. So how many kilometers is each wheel used? The answer is 60, which is E. The sum of the digits of a 5-digit positive integer is 2. A 5-digit integer cannot start with 0. The number of such integers is. Okay, so you've got a 5-digit positive integer like this. All right, now the 5-digit integer cannot start with 0. Well, that makes sense, because if it started with 0 and then you had 5, 2, 3, some number, it's no longer a 5-digit, it's a 4-digit. So obviously that cannot be true. So this is not allowed. All right, so we want to create 5-digit integers where the sum of the digits is equal to 2. So if this is A, this is B, this is C, this is D, and this is E, essentially what they are saying that A plus B plus C plus D plus E is equal to 2. Now, initially you might think, well, how is that possible? You can't do that. It's always going to be greater than 2. Well, not really. You have to use extreme case scenarios. So extreme case scenarios, the very first one that goes through my mind is this one. 1, 0, 0, 0. Right? The smallest possible. Now, what is the sum of the digits? Well, 1 plus 0 plus 0 plus 0 plus 0, which is 1. Does this satisfy our condition? No, it doesn't, because the sum of the digits has to be 2. All right? So this is just an introduction, and hopefully we'll figure this out. All right, so you have an understanding of what the question is asking. You got a 5-digit positive integer, and the sum has to be equal to 2. Well, we tried the 1 with all zeros, and that didn't work. So how about if we tried 2 ones like that? Is that a 5-digit integer? Yes, it is. What is the sum of the digits? Well, 1 plus 0 plus 0 plus 0 plus 1, sum of the digits is indeed 2. So this is one possible integer. How many are there? All right, well, I think I can create a few more. Here's the next one. Very similar. Sum of the digits is again equal to 2. I can create a few more. That one and this one. All of these satisfy our condition that they're 5-digit integers and the sum of the digits is 2. Are we done? Is that it? We've gotten rid of choice A, we've gotten rid of choice B, C. We have 4 so far, right? So is D the answer? I want you to think about this for a few seconds before you choose D and move on to the next question. This question was incorrectly answered by so many students because they forgot one last number, and that is this one, 2000. This is a 5-digit integer that has a sum of the digits as 1. So the total is not 4, the total is 5. So the answer here is E. 4 points on a line segment as shown. If AB to BC, the ratio is 1 to 2, and BC to CD is 8 to 5, what is AB to BD? Okay, let's draw this out a bit bigger. And let's label this. So this is A, this is B, this is C, and this is D. So they're saying that the ratio of AB to BC is 1 to 2. So I'll just call AB X, and then BC is 2, like that, 2x. All right? And then BC to CD is 8 to 5. So BC is 8, we'll call it 8y, and CD is 5, so we'll call it 5y. They want you to find the ratio of AB to BD. All right, let's proceed with this. So AB over BC is 1 over 2. That's the first condition that they gave us right here. And they also told us that BC over CD is equal to 8 over 5. All right? So they want you to find AB over BD. All right? So let's plug in all the variables that I wrote in this diagram. So what's AB? AB is from here to here, and I chose it to represent X. And then BD is where? From here all the way to here. So that's 2x plus 5y, like that. All right? Now, we've got two variables in here, and that's no good. We want to get rid of one variable. But the good news is that, look at BC. BC is represented by 2x, but BC is also represented by 8y. BC is represented by 2x and 8y, so therefore those are the same. So that means x is equal to 4y. So substitute that in here, and we will get 4y in the numerator position. In the denominator, 2x here becomes 8y. And then you add 5y. So we've got 4y over 13y. And then the good news is the y's cancel, so you get 4 over 13. And that is the ratio of AB to BD. So that would be 4 over 13, and that is A. On a rectangular table 5 units long and 2 units wide, a ball is rolled from point P at an angle of 45 degrees to PQ, so like that, and bounces off SR, okay, bounces here, and the ball continues to bounce off the sides at 45 degrees until it reaches S, so it's going to eventually come back. How many bounces of the ball are required? All right, so let's draw this diagram a bit bigger. All right, let's label this now. This is P, this is Q, this is R, this is S, this is 5, and this is 2. Now, this question essentially says that first you start off at P, and you start traveling at a 45-degree angle to PQ. So that basically means that this is 45 degrees, right? That's what the first part says. A ball is rolled from point P at an angle of 45 degrees to PQ and bounces off SR. So it indeed bounces off SR. And then it keeps going like that. So the next place that it's going to go is it's going to keep going like that. All right? And then it will bounce off again, come here, bounce off again, go there, bounce off again, go there, and bounce off one final time and eventually land at S. And I'm going to draw arrows to kind of indicate how it traveled. It traveled like that. All right? Like that. So how many bounces? Well, it initially came here. That's the first one. Then this is the second bounce. This is the third bounce, fourth bounce, and 5 bounces. Now, that's great, but how do you know that? I could have just drawn this diagram and just made it work. But how do you know mathematically that this is accurate, right? Well, that's where this comes in. 45 degrees is the big clue here, because watch what happens. And I apologize, this diagram is not drawn to scale, but for diagram purposes, I hope it helps you. If this is 45 degrees, then that means that this triangle that I just drew is going to be isosceles, and it certainly doesn't look isosceles, so sorry about that, but it is, because if this is 45, then they've told you that whenever it bounces off at a 45 degrees. So this is the second bounce, right? The second distance that it's traveling. So this is 45. And if that's 45, then this is 45, right? Because this is a perpendicular. And therefore, same story. This is 45, and that's 45. So therefore, this is the same as this. Now this distance is 2. So therefore, this distance also has to be 2. And very similarly, if you do it over here, you'll find this is 2. And then you'll find that this is 1 and this is 1. So when you look at these angles and look at the isosceles triangles, you'll see that they add up to the length of the width of the table, and they match the length of the table. So this works mathematically. It's not just a question of drawing it out and saying, oh, it's 5. You also have to understand that this has to work according to the conditions that they give you. So the answer is going to be 5 bounces, which is D. If 1998 is equal to P to the power of S, Q to the power of 2, and R to the power of U, where P, Q, and R are prime numbers, what is the value of P plus Q plus R? So we have 1998, and that is equal to P to the power of S times Q to the power of T times R to the power of U. I like using capitals. It just makes it a little more confusing, because otherwise the T looks like a plus symbol or something. Anyhow, so now what we have to do is we have to factor 1998 into its prime factors. So 1998 into its prime factors, I believe, is 2, and you can do this on your calculator, 3, 3, 3, and 37. So 1998 is divisible by 2, and then keep going, divide by whatever prime factors that you feel that it can be divided by, and eventually you'll get the factorization of 1998. So therefore this is equal to P to the S, Q to the T, R to the U. Now if we combine these into prime factors, we've got 2 to the power of 1, 3 to the power of 3, and 37 is a prime number, so it's 37 to the power of 1. And these are, of course, multiplications. So this represents P to the power of S, Q to the power of T, and R to the power of U. So P is 2, Q is 3, R is 37, S is equal to 1, represented by the 1, T is 3, and U is 1. So they're asking, what is P, Q, and R? P plus Q plus R. Well, P is 2, Q is 3, and R is 37. So P plus Q plus R is 42. So the answer here is C. In the diagram, DEFG is a square and ABCD is a rectangle. A straight line is drawn from A, passes through C, and meets FG at H. The area of the shaded region is. So let's draw this out on a graph, and you will understand this question a little bit better. Okay, so I drew this out, and we can label this now. From here to here is 2, so this point is 2, 0. From here to here is 4, so this is 6, 0. And from here to here is 1, so this point here is 0, 1. This is, of course, the origin, 0, 0. This point here looks like it's 2, 1. And this point here is going to be 6, 4. And this point here is 2, 4. So now they've got this line that is from here to here, that line right there. And it will be very helpful for us if we can figure out that equation, because that will allow us to figure out this point right here, this point. And then we can then figure out, of course, the area of this shaded region. All right? So let's go with that. The equation of any line is of the form y equals mx plus b. And if we have a few points on a line, we can figure out what is m and what is b. So we do, right? We've got this point 0, 0 on this line. So that means 0 is equal to m times 0 plus b. And therefore, b is equal to 0. So now we've got mx plus 0 as our equation, or y equals mx. Now let's substitute that point, and that will help us solve for m. So when x is 2, y is equal to 1. So m is equal to 1/2. And therefore, our equation is y equals 1/2 x. All right? So when x is equal to 6, what is y? Well, y will be 1/2 times 6, which is 3. So therefore, this point is 6, 3. All right? And therefore, now we can figure out the area of the shaded region. So the first shaded region, which is right here, is just a triangle. So its area is 1/2 base times height. The base is from here to here, which is 2. And the height is from here to here, which is 1. So that is just 1. Now, the next shaded region is not a triangle. It's not a rectangle. It's a little bit different. So what I'm going to do is, just to make this a little bit easier, I'm going to draw this perpendicular right here. And that will help me. Because if I can then figure out the area of this full rectangle right here, and then if I subtract from that rectangle the area of this triangle, I will get the area of that shaded region. So first, what is the area of this rectangle? Well, it looks like from here to here is 4, and from here to here it is 4 minus 1, which is 3. So that's 4 times 3, so that's 12. All right? And then now I just have to figure out the area of this triangle right here. So the area of that triangle is 1/2 base, which is 4, times height, which is 3 minus 1, so that's 2. So this looks like 4. So therefore, the area of the shaded region will be the area of the rectangle, which is 12, minus that triangle, which is 8. So the first shaded area, which was in here, is 1, and the second shaded area in here was 8. So therefore, the total is 1 plus 8, which is 9. So the answer is 18. The answer is D. Using only digits 1, 2, 3, 4, and 5, a sequence is created as follows: 1 1, 2 2s, 3 3s, 4 4s, 5 5s, 6 1s, 7 2s, and so on. The sequence appears as, so as you can see, 1, then 2 2s, 3 3s, 4 4s, 5 5s, and then 6 1s, and then 7 2s, and so on. The 100th digit of the sequence is. All right. So we've got 1, and then you've got 2 2s, then you've got 3 3s, then 4 4s, right? And then you've got 5 5s, like that. And then no 6s, no 7s, don't get that in your mind. And you go back to 1s and 2s, but this time you've got 6 1s, like that. And then 7 2s, and so on. So I just drew this out so that you can kind of understand what is happening in this question. So how many numbers did we have? We have 1 of these, we have 2 of these, 3, 4, 5, 6, 7. All right? So if you want the 100th digit, which is what they're asking for, you have to understand that this is going to keep on going. So it's going to be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, and so on. And eventually, you will get to the 100th digit. So it's very important to understand this really cool mathematical formula that says that if you have the sum of any consecutive numbers like 1, 2, 3, 4, 5 all the way till n, that is easily calculated by n times n plus 1 over 2. All right? So if we had, let's say, n is equal to 20, and you wanted to find 1 plus 2 plus 3 all the way up to 20, instead of manually doing it, you can just use this formula, n times n plus 1 over 2. So you'd put in 20, and you'd get 20 times 21 over 2, which is 10 times 21, which is 210. So it helps you, especially when the numbers are very, very large. Now in our case, we've got 1 plus 2 plus 3 plus 4 all the way up to some number, and that equals 100, right? Because they're saying the 100th digit or 100th number is what they're interested in. So this is n times n plus 1 over 2 is equal to 100, and therefore n times n plus 1 is equal to 200. Now I'm certainly not going to make this into a quadratic equation and solve, but what I will do is I'll just take the square root of 200, and the reason is because n times n plus 1 is very similar to n squared, right? So if I can kind of get an approximate value, I can work with this. The square root of 200 is 14 point something, all right? You can check that on a calculator. So it looks like this is going to go up to about 14, approximately. And if it does, we will get a very good idea of how this works. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and I'm going to put the 14th here just in case we need it. So let's add it all up and let's see what we get. So 1 plus 2 all the way up to 13 is 13 times 14 over 2. We're using that formula, n times n plus 1 all over 2. So 13 times 14 over 2 is 13 times 7, which is 91. All right? So that means that we are sufficiently close. The first 91 digits involve this, which is 1 1, 2 2s, 3 3s, right? 4 4s, 5 5s, and then 6 1s, 7 2s, 8 3s, 9 4s, 10 5s, and then we've got 11 1s, 12 2s, 13 3s. And that by that point, we've reached the 91th digit. So the last 9, 92, 93, 94, 95, 96, 97, 98, 99, and 100, 92, 93, 94, 95, 96, 97, 98, 99, and 100 are what? Well, that's where this one comes in. It will be 14 4s. So this is a 4, 4, 4, like that. So I hope that made sense. So therefore, the 100th digit is a 4. So the answer to this question is D. Driving between two towns at 110 kilometers per hour instead of 100 kilometers per hour saves 9 minutes. The distance in kilometers between the two towns is. All right, so we've got town A, we've got town B, and let the distance equal x. All right, now kilometers per hour, that is speed. So that should let you know that speed is equal to distance over time. All right, just a standard formula. So we can manipulate this formula and make it into time. So time is equal to distance over speed, like that. And they've given us two scenarios. One is 110, one is 100 for speed. And therefore there will be 2 times. So we'll call them T1 and T2. So the first time is when you are traveling at 110 kilometers per hour. So the distance is x and the speed is 110. The second time is when you're traveling at the next speed. The distance is the same, x, and the speed this time is 100. All right? Now, which of these times is greater? Well, when you are traveling at a slower speed, it will take you more time. So the slower speed is 100. So therefore T2 is greater than T1. All right? But by how much is T2 greater? Well, they tell you by 9 minutes. There's a 9-minute difference between those two times. Now, what's important is that they've given it to you in minutes. 9 minutes. But we have to convert that to hours because these are in hours, right? They're in kilometers per hour. We can't put minutes and hours into the same equations. It won't work. So 9 minutes converted to hours is pretty straightforward. 9 over 60. So that would be 3 over 20, I believe, if you bring it down to lowest terms. So that basically means that T1 plus 3 over 20 is equal to T2. All right? Now, the good news is that the distances are the same for both scenarios. So if we solve for this, we get x is equal to 110 times T1. And if we solve for that, we get x is equal to 100 times T2. So x is equal to that, and x is equal to that, so we can equate them. So that means 110 T1 is equal to 100 T2. All right? And then substitute this. So we get 110 T1 is equal to 100 times T2, which is T1 plus 3 over 20. So 110 T1 is equal to 100 T1 plus 300 over 20, which is 15. And we've got 10 T1 is equal to 15, and therefore T1 is equal to 15 over 10, which is 1.5. All right? So what does that 1.5 represent? It represents time in hours, 1.5 hours. Now that's not what they're asking for in the question. They're asking for the distance between the two towns. So they're just asking you to solve for x, which is what we call the distance. Well, we can use any of these formulas to figure out the distance. We can use this one, for example. So that means, since we already simplified it, I don't need to simplify it again. X is equal to 110 times T1. So 110 times 1.5. And that is 165. And what are the units? Kilometers. So those kilometers, 165 of them, are the representation for the distance between the two towns. So the answer here would be C.